Synchronous generators comes under the category of alternators, which is used to convert mechanical power derived from steam, gas, or hydraulic turbine to AC electric power. Synchronous generators are the primary source of electricity that we consume in our home. It rotates at constant speed. Synchronous generators are synchronous during their operation means electrical frequency is synchronized with mechanical speed of rotor. Relation between electrical frequency of stator and mechanical speed of rotor as shown. Frequency equals Np upon 120. Here F electrical frequency in Hzn. Speed of rotor in rotation per minute. P number of poles. Electric power generated at 50 or 60 Hz. So rotor must turn at fixed speed depending on number of poles on machine to generate 60 Hz into pole machine. Rotor must turn at 3600 R per minute and to generate 50 Hz in 4-pole machine. Rotor must turn at 1500 R per minute. To operating principle, the rotor of the generator is driven by a prime mover, turbine, pistons etc. ADC current is flowing in the rotor winding, which produces a rotating magnetic field within the machine. The rotating magnetic field three-phase stator winding and induces a three-phase alternating voltage in the stator winding of the generator. 3. There are two types of rotor. First one salient pole rotor and second one is non-salient pole. The non-salient, that is turbo generator, uses for 2 to 3 pole. The salient pole is used for above 6 poles. When there is no load on alternator, there is no armature current flow. Because circuit is not complete as current flow in circuit only. The rotor acts as an electromagnet when it gets magnetized from external DC source during rotation by prime mover. Here rotor if salient and non-salient poles. Here excited for DC supply to field winding is mounted on rotor shaft in synchronous generator. Rotor winding energized by DC source to develop rotor magnetic field. Rotor is turned by a prime mover, producing a rotating magnetic field which induces three-phase voltages in stator windings in general. Rotor carry the field windings, while armature windings or stator windings carry the main voltages of machine. Cylindrical rotor, that is turbo generator, has high speed 3600 revolution per minute and has 4 2-pole and 1800 rpm per minute for 4-pole I. It has direct conductor cooling using hydrogen or water as coolant until maximum rating up to 2000 MVA constructed. It's a gap uniform, smooth solid steel cylinder having no F slots to accommodate field coils. Rotor have small diameter and large axial length. Mechanical vary strength, so it is preferred for high-speed alternator. Turbo alternators 1500 revolutions per minute to 3000 rpm. Application: steam turbine. Electric motor direct access quantity is one whose magnetic effect is along the field pole axis. A quadrature axis is one whose magnetic effect is along the perpendicular to field's pole axis. In this figure, steam rotates turbine and turbine rotates rotor as both are coupled. This is the stator and rotor of turbo generator. You can see more detailed images on our video in description box. Stator of steam turbine and hydro turbine the same, but rotor construction is different. Here rotor of hydro turbine. Here wedges in the slots of field windings interconnected to form a damper case, or separate copper rods provided underneath the wedges during unbalanced or transient condition. Stator and rotor fields may vary in magnitude with respect to time, have different speed. Currents flow not only in the field in stator windings, but also in damper windings if present, and solid rotor surface and slot walls of round rotor machines in figure. The flow path of eddy current through stator conductors in figure 2. The eddy current flow through rotor conductive paths. Most hydraulic turbines have to turn at low speeds between 50 and 300 rpm per minute. A large number of poles are required on the rotor. This the S direct axis and this is quadrature axis. This is picture of 6-pole salient alternator. Projected pole type, as all the poles are projected out from the surface of the rotor. The rotor have large diameter and small axial length. Mechanical strength is less, so it is preferred for low-speed alternator 125 revolutions per minute to 500 revolutions per minute application. Water turbine IC engines normally have damper windings or mortises, non-magnetic material, usually copper rods embedded in pole face connected to end rings to form short-circuited windings. Damper windings may be either continuous or non-continuous. Space harmonics of the armature MMF contribute to surface eddy current. Therefore, pole faces are usually laminated. Here are the continuous and non-continuous dampers. Continuous mainly uses for small alternator and non for large generators. Phasor diagrams for unity. Lagging leading power factor. You will understand thing in amateur reaction video. Now difference between salient rotor, cylindrical rotor, salient, projected pole, while in cylindrical is cylinder form. In salient or projecting pole type, non-uniform air gaps or non-sinusoidal flux cutting, so use damper winding, while in non-salient it is uniform, so smooth flux cutting in salient. XDD excess in reactance is not equals to XQQ access synchronous reactance, while in non-salient it is equal. It is used in low-speed machine and this is used in high-speed machine. It has small core length, large diameter to accommodate large number of poles. In cylindrical pole, long length, small diameter to limit large centrifugal forces due to high speed. used in hydro generator in which rotor is driven by hydro turbine is designed with this pole. Turbo generator in which rotor is driven by steam turbine. Under fault, there are more chances of deformation of rotor due to non-uniform air gap. But in turbo generator under fault, there are less chances of deformation of rotor due to uniform air gap. Output waveform is not sinusoidal, more harmonics, while in this output waveform is more nearer to sine wave. Output power is the sum of electromagnetic power and reluctance power, while in cylindrical only EMF power. Here power angle sine delta is from 80 to 85 degree. Here it is nearer to 88 to 89. 8. For balanced steady state operation, these conditions should be followed. Net MMF wave due to the three-phase stator windings travels at synchronous speed, appears stationary with respect to the rotor, and has a sinusoidal space distribution. MMF wave due to one phase. This is the sinusoidal wave of three-phase. 9. Equivalent circuit diagram. To develop a relation for V-phi as terminal voltage of generator which is different from internal voltage A because of following reason. To study that equivalent circuit is needed. Reasons for V-phi to be different from EA1: distortion of air gap, magnetic field due to current flowing in stator, called armature reaction. 2. Self-inductance of armature coils. 3. Resistance of armature coils. 4. Effect of salient pole rotor shapes ignored as machines have cylindrical rotors. Here are the three-phase red, yellow, blue individual circuit diagram of stator winding with rotor circuit. Here DC voltage from prime mover applied to rotor field circuit. Here field current IF with resistance and inductance, and this is induced EMF and terminal voltage. There is some effective armature resistance and reactance by stator three-phase windings. 10. Generated voltage of alternator is given by generated DMF is equals to K omega P. Here P is flux, omega is angular speed, and K is machine constant. Here is the non-linear graph of field current and generated voltage or induced EMF. This is power. Output equations in actual power and reactive power. Here are the losses in input power, that's stray losses, mechanical or rotational losses. Call losses, that is eddy current and hysteresis and ohmic losses. Before connecting a generator in parallel with another generator, it must be synchronized. A generator is said to be synchronized when it meets all the following conditions. The RMS line voltages of the two generators must be equal. The two generators must have the same phase sequence. The phase angles of the two phases must be equal. The oncoming generator frequency is equal to the running system frequency. For infinity pass voltage and frequency are constant and synchronous reactance is 0. An infinite bus is a power system so large that its voltage and frequency do not vary regardless of how much real or reactive power is drawn from or supplied to it.